Good afternoon, everyone, and welcome to the brand new Sheffield DevOps online only meetup. Sorry that it's just me here on a screen after that suspenseful build up from the countdown. Apologies if it's a bit anticlimactic, but I'm doing the best with what I've got. So yeah, welcome everyone. We are starting this meetup up again. As I said, we're going for an online only approach to start, just to try and get people back through the door, so to speak. But we are going to be having some in-person meetups hopefully soon. More on that later. At Sheffield DevOps, we have a code of conduct. This is obviously more important when we are in person than on these online meetups where interaction is unfortunately a bit limited. But we ask that you keep this in mind when you're asking questions and conversing with the speakers and with each other in any online forums that have the Sheffield DevOps name anywhere near them. We've got a fantastic speaker today. If you have any questions for Mick as he's speaking or when he gets to the end of his presentation, if you just drop them as a comment in the YouTube live chat thing next to the live stream, then we can feature those on the stream and get Mick to answer them after he's finished speaking. I've just got a couple of things to run through before I bring our speaker on. So CFP. The CFP remains open and will basically be a perpetual CFP. We're always on the lookout for talks. So if you have an interesting talk around DevOps or DevOps practices or SRE, platform engineering, behavior, psychology, really anything within reason that can be some way tangibly related to DevOps and its surrounding disciplines, then please get in touch. You will have seen our little ticker along the bottom begging for followers on LinkedIn. We can't stream to LinkedIn until I think we've got 100 or 150 followers. We're quite a bit off that at the minute. So beg your friends and family to follow us as well. And then that means we can stream to both YouTube and LinkedIn and improve our reach, which is only a good thing. Finally, before I get onto the speaker, we are looking for sponsorship. Now, this can be one-off sponsorships for in-person events. It can be rolling sponsorships on a monthly basis to help with our streaming costs so that we can get fancy streaming features like removing the StreamYard logo from the corner. So yeah, please reach out if you are interested in sponsoring, and we can have a good conversation. So I'm going to introduce you all to our speaker. Our speaker today is Mick. Mick is a tech leader with experience in both software engineering and architecture. It's all about empowering engineers to drive innovation and technical excellence, and is going to be talking about chaos in serverless environments, which for me is an absolute godsend. I love hearing about talks like this. So Mick, if you're good to go.
Yep, ready when you are.
I'll send you slides over.
Hi everyone, I'm Mick. First off, thanks to all for arranging this. I think DevOps is an important part of the modern engineering world, and these meetups are valuable for trying to get the juices flowing for ideas for who's doing what where. As all mentioned, I'm a tech lead. I've worked in all kinds of weird and wonderful industries. But one thing that always floats to the top is the fact that outages happen. You just can't engineer your way out of them at all. Your best option is to embrace it and figure out how to deal with it properly. And that leads us nicely into chaos engineering, which, for those of us who are not familiar with it, so that's kind of gone off the burn. It was all the rage around 2018, but it seems to have died its death just a little bit. Chaos engineering is the art of introducing turbulence into your systems so that they become more robust and resilient. The first thing I always have to say when talking about chaos engineering is it's not about breaking production, which was a horrible tagline that it got for a very long time. People used to think you just go along and just rip out the DNS or kill a database and everything will be fine. 100% what it's about, we're trying to keep production in a better state. The basic premise is that muscle memory can only be built, resilience realistically can only be built by experiencing the downsides of these events. By actually experiencing an outage, you gain an appreciation of how to prevent it going forward. Rather than taking the less DevOpsy approach, which is let it fall over, get everyone in the world on a big call, run around for a while, try and kludge it back together, consider it done, we try to take a more scientific approach. We produce a hypothesis. If I kill this database, then this service should fall over onto this one, and things should be back to normal within 10 seconds. The important part of the hypothesis is it must be testable, must be measurable, and then it must be something you can actually employ and then roll back afterwards. They become more elaborate as time goes on, but you can start quite small. An important part that I always put on these slides is that you must remember why you're doing these tests. It's very, it's kind of like disaster porn, to be honest with you. You start breaking stuff, you can keep breaking stuff, and eventually you'll just realize all you've got good at is breaking stuff. You kind of got to bear in mind the business case that you're trying to back up with why you're doing this. And that generally is, we want the users to stay happy. Happy users spend money. Sad users don't. So we want to try and work towards that. So there's two major flavors to chaos, serverless or serverful. You have the chaos within your systems and the chaos that are happening all around your systems. And the around the systems are the ones that cause the most pain to a serverless infrastructure, mainly because serverless systems are much more exposed to the network than anything that's serverful. We all know that you get a small runtime, memory bound normally, and it's very event driven. Oftentimes the entire runtime environment is disposed as soon as that event is handled, successfully or not. But that means that if you, for whatever reason, can't get the event into your system, or if that serverless function can't talk to the network to get the result out, it fails and you get yourself into a horrible mess. As I mentioned, runtime constraints, memory is a very common one. Obviously, if you have something happening and something around it has become very slow, you're going to hit all kinds of problems in your runtime constraints. You're going to have potentially CPU issues, which tend to happen a lot if you have persistent database connections where you're doing a lot of ping-ponging. You might be streaming a lot of information before you get to the good stuff. You run out of RAM. Going in serverless is not a good place to be. Distributed systems, unfortunately, have concrete dependencies. We abstract them away in the code, but they're always going to be there when we actually deploy this stuff. This is actually one of the key things we're testing when we do chaos engineering. We're going to look at these concrete dependencies and say, what if? We can try and minimize that, but it's expensive, and we'll come across that in a little bit when we start thinking how to run a test. Most people, when you talk about resiliency, the first thing they say is, well, we just take it off the hot path. We make it async. That's a simple way to solve the problem. And in a lot of cases, it will preserve runtime experience if the rest of the world catches on fire. So long as your queue that's feeding your services are ticking over nicely, the service won't care. It'll just keep going, catching up when it can. The problem is that not everything is asynchronous. And introducing a bridge between a synchronous system, such as a web request, and an asynchronous system, such as a basic event handler, or if you really want to go nuts, something like CQRS, you're going to get yourself into a horrible place where you've spent a lot of money and you've dedicated a lot of effort to solve a problem that you might be better off solving a different way. A nice sort of follow on from the asynchronicity is dead letter queues. If you're doing async, handling an asynchronous event, and you're not using a queue, will do. Basically, you're missing the whole point of async. If you're just consuming off of a simple bus that doesn't let you replay stuff, you're losing an awful lot of capability there. So assume that you've got that. When you fail to handle it, you don't really want to just put it back on the same queue forever. You're going to need to let it dead letter. If it's bad data, letting it go in through there, say there's only 1% of all messages are going to meet that criteria. Eventually, you're going to fill that queue up with nothing but bad messages. So you wind up getting a very poor return on processing to successful processing. The thing with the dead letter queues, dead easy to set up. The question is, what do you do with stuff that's in there? Dead letter queues tend to grow exponentially. They never get actually analyzed. There's no desire to figure out how a dead letter queue should be used. What is the purpose of it? Why is it there? Bear it in mind, it's part of your disaster resilience scheme, and it's something that we would follow as part of chaos. And I put this bit about falling off the edge of the map. In essence, resilience is expensive. And if you push yourself beyond basic norms into unusual patterns of handing things between regions or systems, going from serverable to serverless and back again, you'll start adding cost. Sometimes dollars, other times just simply cognitive load, which in my mind is a worse cost because it winds up hurting your entire team. So just a thing to be aware of if you're trying to preserve the world around your services. And the question then is, what do you do within them? So again, taking the idea that serverless systems are going to be part of an overall tool chain, a processing chain of things to do a useful job, you might need to come up with a mechanism to actually have your services act in a chaotic way. It's actually a pretty good idea in practice to have your systems really messed up every so often. To be completely honest with you, it sounds sort of counterintuitive, but it's a brilliant tool for dealing with expectations of other services around you that may depend upon you. And you can control this completely, but you should make it configurable. So we are kind of getting into how you would run a test now. So imagine the simplest test you could do within a service, which is, I am going to succeed 3 nines of the time, 99.9% of the time. What you should be doing really is ensuring that you succeed 99.9% of the time, but very little more. Start introducing errors as a response. Simple 503, that should encourage anyone downstream to retry, but it helps to build muscle memory. You aren't always going to be there. Sometimes you're going to fail, and you should fail. This is STEL, so status codes, that's that one. Return a 503 every now and then. Basically throw an elbow, just to see how the rest of the world performs. If it looks like the rest of the world is on fire, wind it back. Make it configurable. Give yourself a short circuit to turn this behavior off. Throughput is another one, which is really quite an important one with the serverless world. So how much concurrency should you actually have in a serverless function, be it K8s, K9s, or Knative, whatever, or if you're going to run in AWS Lambda. If you just let it gobble up all of the available throughput in the world, and this can happen with your chaos experiments if you inject a lot of data to start them going, you eat all the resources for the entire account, and you wind up having horrible knock-on effects. And that breaks production, which breaks cardinal rule number 1, never break production. So what we actually do is always keep an eye on throughput. It's very important. If we keep an eye on throughput, then we're able to produce a test which is throttled appropriately, but also has a knock-on effect to those who are trying to get information into us, more importantly with synchronous calls. So if someone's got a Lambda function backed up by a load balancer, for instance. Errors is another nice one that you can inject yourself. You can make it arbitrarily just die, throw an error. You got to be wary of how that happens, though. That tends to be the way to go about things if you need to break stuff in an asynchronous process, because you don't have the feedback loop. So in the assumption that you want to process an order comes in on a queue saying this order needs to be processed, you occasionally might just want to throw an error. If you've architected your system properly, that should be a very small blast radius anyway. But not all systems are particularly well architected, and part of your experimentation there would be, the hypothesis, would be, if we raise an error in this service, no other service is affected. It seems like a silly test to run, but it's also a very valuable test to do because it tells you the blast radius of your service. And L in STEL is latency, which again is another dead easy one to drop in there. Although it can be an interesting one because of the runtime environment with serverless. So again, because we're working within generally a 15-minute max window, although if you're using that much, you probably should break the job down a little further. You might run out of time just by injecting latency. There are some nice little capabilities in AWS to find out how long is actually allowed to remain. And you might just want to delay it a little bit between the time it's going to time out and the amount of time you have left when it's finished processing. And again, this is powerful, less so with async, but certainly with synchronous calls, to try and encourage your caller to develop their own resilience, that they might have to wait sometimes. And this is kind of the purpose. We're trying to build a lot of muscle memory beyond our teams, especially in a distributed system. We're all part of a greater whole. You can't really just do something in small bits. The whole journey needs to be more robust. Costs are an interesting thing when it comes to serverless. Most people at this point are familiar with serverless. Just dollar costs are directly related to how long your process runs and how much resources it uses. So it's a very simple function there. So if you get this thing spinning, you're going to be paying. Ironically, that's not where most of the money goes. If you actually look at your billing, it's a bit of a sort of cultural misnomer that just doing more processing results in more cost. It's true, but most processing is valuable, so it's not really a cost, it's an opportunity to add more value. Errors are different. Traditionally, what you'll find is you will log more information and respond more as an engineer to an error than a success. So there is a natural increase in the cost of any outage, any error. And if you're injecting them and you're causing errors to happen, you effectively gum up systems in non-standard ways, much more so than my service called your service and your service told me it couldn't do the job. The next step is me figuring out why. And there is a cost to that. Cost in time, cost in cognitive load, cost in effort, possibly a cost in runtime, certainly a cost in CloudWatch. If you do one of these tests badly, the whole thing can spin, write a huge amount of error log to CloudWatch, and you're stuck with a bill that maybe is 3 or 4 times what you expect. In the same sort of vein, the account level effects are the same sort of thing. An awful lot of the restrictions that you get on serverless are going to affect your resources of the account itself. I know there's a bit of a hype cycle at the minute around creating accounts for all kinds of granularities. It's probably better just to restrict them and keep that restriction as a constant within your test. You don't really want to have more than, say, 50 concurrent invocations of a thing, even if you send 20 million messages into the queue that powers it. And then the unhappy path can run into time and memory constraints, which, again, we've kind of covered already. If it sits there spinning, you've only got so much time for it to do that before it bombs out. And then regardless of what happens, that goes back on your queue, or it returns a bad error code, which probably won't be a well-described error if it's synchronous. If it's non-synchronous, it just sits there in a queue and you wind up with a queue that's full of nonsense. So just another thing to be wary of. So I went through a lot of stuff there, a lot of theory. What we're talking now, though, is how would you do it? Now, the upside is, well, first of all, don't try and do it manually. Think of it, this is just an IAC all over again. Doing it manually is a recipe for disaster, not because it's hard to break a thing manually, it's very hard to recover it. If you tear down a database, it's very difficult to then set that database back up in such a way that everything is just tickety-boo. And that's the key thing of a chaos experiment. You have to be able to roll it back to the last known good state. Assume that you've got the ability to do it. You pretty much have whatever fun you want, really, within the realms of your test. You know, if you assume if we kill this server, another one will start up. Pretty simple test. DNS poisoning was an interesting one. I saw someone run a test for. It was rather mental because they ended up having to put a bunch of extra records in there so that occasionally a function will go in and double check that the DNS hadn't been poisoned, which is way overkill, but they wanted to do it. Flooding a network, again, pretty straightforward. You're just basically DDoSing yourself. You might have to build a little bot farm to do it, but you can do it. Nonsense data, deleting them, the list goes on. We all know that there are bad things you can do. The important thing is that you must be able to hypothesize before you do it. And critically, you must be able to get back to the last good state at the point the hypothesis was made. So if you think, great example from Netflix's days, they used to tear down regions, which meant they needed the ability to completely rebuild a region from scratch. If you haven't got that capability, get that first. Very, very critical. Luckily, there is options that don't mean you have to do the heavy lifting yourself, just the same as infrastructure as code and CI/CD and whatnot eventually got commercialized. Chaos Toolkit, actually the company I used to work for, Reliably, they build the Chaos Toolkit. It's an excellent piece of open source technology, probably the best in the area, the best in show. Gremlin's pretty good too. Fault injection simulator, they're all there. If you can use them and you want to give this a try, I'd like to go through how these work, but if there's interest in it, I'll do a deep dive, a demo for maybe another talk, and we'll go into it slightly more. But basically, these things exist to say, I kill this, we monitor this, this should happen. If it doesn't, or regardless, actually, put it all back to what it was. And it all comes back nicely. And one last time, don't break production. If you get to the point where production is down, you have gone way past what your experiment should be showing. You always need the ability to roll these things back, but you don't want to break production. So I know that was slightly more I don't know the word actually now. It's a little bit more talky than I would like. I'd like to be demonstrating some of this stuff, but it can take some time to set up an experiment and run it over time to see how this stuff works well. Hopefully, though, by the end of this talk, you should now know what you don't know, which is kind of the reason we do chaos. We don't know, we don't know what will happen if we kill this database. Not for sure. We need to prove it. So this will help you find out what happens when that database goes down. There's still an area that you don't know what you don't know. There's always more stuff that can cause problems. So get ready to write more tests, more experiments as time goes on, and you decide you need different stuff. It gets expensive when you start switching architectures, so it can also be something to filter in to that sort of change management process. You can try and write serverless systems differently, so that generally speaking, async wherever is humanly possible, because it does give you an excellent blast radius reduction, but it also makes feedback very, very difficult, and that can be an interesting thing to test. And most importantly, you shouldn't be bankrupt, but there is a slight little disclaimer on the end there, because I promise nothing. And that's it, guys. Thank you very much for listening.
I'm muted, aren't I? I like the disclaimer on the end there. It saves me having to add one on there myself. So yeah, pop any questions that you've got into the live stream chat if you do have any. I didn't know you used to work for Reliably. I did it quite early on. I mean that's the one I tended to go for. Have you like used Gremlin as a kind of in the same way that you've used Chaos Toolkit to be able to say what the benefits of each one are?
I mean, the key difference with Gremlin was support. With the Chaos Toolkit being open source, it did a lot more, to be honest with you. But Gremlin also had a different runtime environment. So Gremlin would release what they called gremlins into your infrastructure, and then you would effectively control them remotely, which was a little bit scary because you give these things quite heavy permissions and then hope no one else talked to them without you knowing. Chaos Toolkit was different. It was very much fire and forget. So you set up a particular experiment. It wasn't the nicest experience, to be honest with you, but it's pretty good. It does work. And then that would just run until completion and then wind itself back.
Cool. Yeah, I think Gremlin is very much a point and click type, setting up experiments and things like that, isn't it?
Yeah, it's got a lot of pre-done runbooks. I think the last time I checked, the Chaos Toolkit was building up an awful lot of runbooks. It's come quite a long way since I was at Reliably. It's been a few years now. But yeah, effectively, the pre-made stuff is pretty good. The thing I always found with the pre-made stuff is it didn't think big enough. It was very much stuff like, if I kill an EC2 instance, a new one comes back. Well, yeah, that's nice enough and whatnot. But what happens in that sort of 5 or 6 minute window while it's trying to spin up? How do you recover from that? How do you manage it? Yeah. So you do sometimes have to go a little bit bigger.
Yeah, that makes sense. Okay, so not a question here, but we do have someone who's actually taking you up on that offer of coming back and doing a more of a hands-on thing. So I'm not even sure how live demos would work with this streaming system that we're using, but you know what, I'm sure we could figure something out, even if you have to, film it and play the video.
We'll figure something out.
Yeah, that's
the interesting bit is trying to get beyond the simple tests. The simple tests are stuff you could just pick up by going to Chaos Toolkit and just running through some of their simple stuff. But thinking about the bigger blast radius and some of the unhappy path stuff, that's the more interesting bits.
Yeah, that's it. Alice has started looking into Chaos Toolkit as well. So I think you're getting a lot of recruits. It's a shame you don't work there still, because you probably get to know something.
Yeah, we did a few extra bits as well around service levels, which I don't think was quite as well adopted. So if you see that bit, ignore it. It doesn't work so well. But the Chaos Toolkit stuff, that is champagne.
All perfect. Right. Well, listen, Mick, thank you very much for your talk. It's been insightful. I'm a sucker for chaos engineering all the time. So anytime that I get to hear someone talk about it or talk about it myself is brilliant. In fact, Alice has actually just dropped in a question at the very last minute. So you know what, we'll let them get that question in.
Yeah.
Here we are. So how do you scope the chaos? Do you involve all the other teams that are using your services? That's a good question.
That's a really good question. And it very much depends on the culture of the place you work. So if you're building things which are synchronous, so web requests are the most obvious one, you're going to have to, ideally, as part of the release process of that service, you would offer some sort of service level. That's even if you're a back-end service talking to a website, for instance. Offer that service level and then try and stay within it for your chaos test. If you haven't got a service level, and no judgment if you don't, most people don't, it's best to have the conversation. Tell them that we're going to do a little test here. It's like it might produce, ideally even share the entire hypothesis. That way they can see what should happen and what might not happen. It'll at least give someone a bit of a heads up, just in case your service suddenly starts causing a huge amount of traffic change.
Yeah, always better to over communicate when you're at risk of breaking production, isn't it?
Well, that's the thing. We don't break production. I'd say that if you were at genuine risk of breaking production, don't. You're better off actually have that conversation and then decide a smaller test to start the ball rolling, and then start thinking service levels first. Get those communication pathways open, get them working, and then start saying, well, what if we failed every 1,000th request? What would that actually look like? It just puts it in people's minds. It probably means that your test might take longer to run and much longer to stage, but it does mean that you aren't going to be on the hook for costing your company user experience.
Yeah, that's it. And I guess that's where the whole conversation around, like, you've mentioned about service levels, but the whole SRE workbook with your error budget and things like this, how many requests you're allowed to fail and what you do with those failed requests. You can just have rubbish infrastructure. Or
There's a huge number of ways you can be burning through. Effectively, when I think of SRE, service level objectives, all that kind of stuff, it's effectively goodwill, and it all comes down to how much goodwill you're willing to burn if this goes wrong. Ideally, he wants to be zero, but if you do it badly, it could be quite poor. Again, depending on culture. Some cultures embrace the fail fast and learn. Others only say they do.
But really, it's too big to fail.
Too big to fail.
That's it. But yeah, again, thank you very much, Mick. I'll just briefly touch on what we've got planned for next month as well. So next month we have Matt Saunders, who's going to be doing a talk. It's called Git Good. And it's all about how Git works under the hood and how you can use the knowledge that you learn from that talk to be a more effective engineer, I guess. So we're looking forward to that one. We will also be trying to do some sort of Christmassy type in-person meetup. Still very early stages. So if anyone wants to, do any organizing or sponsorship maybe around that, then do let us know. Yeah, we'll see you next month. I can't remember the date that I put, but I think it's the second or first Thursday again. But literally after we finish this one, the next talk will be advertised and everything. So I'm trying to be more organized with it. You might spot this. So yeah, that's it. Thank you everyone for joining the stream. Thank you to Matt, who's just told me it's the 5th of December. And thanks again to Mick for sharing your experiences with us. All right. Thanks a lot.